Hey guys, we have a small crowd here, so we'll keep it intimate, right? I'm Sachin Dhingra. I manage design IP at Cadence, and we'll talk about how to build the future faster, or what I like to say, I want to be your BFF. You guys make the connection there. So, I'll show you how I become your BFF. Okay, first a little quiz actually. So, oh man, this was not supposed to show up, but give me three reasons why commercial. First of all, do you guys understand what commercial IP is? Show of hands. Who does not? Who does not understand what commercial IP is? Okay, everybody knows. Makes my life easy. Okay, give me three reasons why commercial IP is taking off and why is it getting so much entertainment right now. Design cost, you already saw that, so no points for that. SoC design cost, okay. Speed, so yeah, speed, okay, that's close enough, right? The speed's increasing, so I'll put it under complexity, right? And then time to market again, one more good point, right? You want to get to the market faster. Again, with kind of ties in with the complexity part of it, right? And the third one we think is actually the consolidation in the industry, and I'll tell you how. First of all, cost. Obviously, it's been doubling every node. You're looking at over $300 million to do a 16 nanometer design. That's a lot of money, right? Anything you can do to save money there is huge, and I'll tell you how commercial IP saves you cost in developing an SoC. Okay. M&A, consolidation. There's a lot of companies out there. In the past 2 years, there was consolidation of over $250 billion worth. So this company shrunk from maybe 100 to 10, right? You would think they would acquire a lot of IPs, that they won't need a lot of IPs from outside. But it's actually the contrary. You actually focus on what you do well. You differentiate on your IP, and the standard-based protocol IPs you outsource from vendors like us. Third one, complexity. I love this graph. Right? 5 years ago, you used to have maybe 10, 15 protocol standards. Now I can't even count how many. And this is not just new protocols coming up. First of all, it is new protocols. You have new applications. Data center wants one type, mobile wants one type, automotive wants another type, right? So new protocols, first of all, application specific. And the other aspect is all these old protocols like PCI Express or USB, they're having different iterations going from USB 1, 2, 3. You still have to be backwards compatible. So that has created so many different protocols. They're very complex. The cost to develop anything and the time to develop everything is very high. So these are the biggest reasons. And the other factor that I kind of forgot to mention was the consolidation has created voids in the industry too. There's a lot of smaller companies that have come up building silicon solutions. They need IP because they don't have the resources to build the IPs in-house, right? So what are the benefits of commercial IP, right? Focus, I said this first. If you're building a chip or a system or a solution, focus on what you do well. You don't need to go build a protocol IP which is already there off the shelf, right? Let us do that. That's all we do, right? So we've already done the hard work. We amortize our cost, so we will provide you the IP. Access to new technologies. So we work with partners like TSMC and foundries. We get first dibs. Now, Cadence being a big EDA company, we're the first ones to get you tools, first ones to get access to any new technology that comes out. Right? So we do that. We work on the latest standards, and we develop a solution for the latest process nodes. Time to market. The gentleman here brought up that point earlier. Time to market's huge. If you start developing your IP in-house, right, you will need a dedicated team. You'll need experts in-house to develop the IP. We have a dedicated team just looking at an IP and doing that full time. That's all they do. So the last aspect is the knowledge that you get, because that's what they do. We have built IP that's gone across multiple customers, multiple designs. We have protocol gurus in-house that will help you, work with you, and support you to make sure that IP that you use gets integrated correctly with the right architecture and it meets your needs, right? These are some of the quotes we got from some of our customers. They basically are saying, I'm never building a standard-based protocol IP. No point. So the high level, we want to be, as I mentioned earlier, we want to be your BFF, right? That's what I want to do. I want to become your trusted partner. And how do we do that? I'll go over that, all those points. But at a high level, we work with you. You use your knowledge. We provide you the building blocks, and we help you build your future faster, which is essentially building your device or your solutions faster. So first of all, we provide you breakthrough technology. We'll start with, I'm not going to go over all of them, but different market spaces. So you're looking at data center, DDR5, CCIX, it's a new standard that started, PCI Gen 4, we have them. We have them on 7 nanometer. We've had them on 16 nanometer for a while. Most people are just starting with that. With us, you already have them. DDR, we have the fastest data rate running in the lab now, available, silicon. Most companies haven't even started that design, right? So looking at that, and going even LPDDR for the mobile space, because data is king now. You need that throughput. And then on the automotive space, this is an interesting topic that has been getting a lot of attention lately. How many people understand the terminology being used here? Does anyone know what ASIL means? Okay, so are you in the automotive space? Okay, which company? Okay, obviously. Anybody else? So I've got one person. So obviously it's not as popular of a term, but it's becoming very, very popular. ASIL is automotive safety integrity level. This is basically a standard body that looks at your IP and tells you, it defines the methods and the process to make sure your IP is safe. Everything is traceable. So in automotive, one of the biggest things is safety. If something goes wrong, your human life is at stake. When a human life's at stake, there's a lot of checks and balances that go into place. So there's procedures that need to happen. You need to make sure everything has a backup, there's redundancy, there's safety integrated in the IP. So you have different vendors like Bosch and other automotive vendors, Mobileye. They develop their chips. Their components are ASIL certified. What we do is we do the extra homework in the back end. We'll make our IPs ASIL ready, which is basically it's ready for their consumption, so they don't have to do the work. They can get to market faster. Okay. We also provide a comprehensive solution. What do I mean by that? So it's two parts, right? I'm an IP vendor. I'll give you an IP, but I just don't give you an IP. I give you the full solution. I'll give you IP, whether it's a PHY, a controller, a driver. I'll give you a driver customized. I'll give you a verification environment with it. And I don't stop at the chip level. I'll give you the simulation models, package design models. I'll help you with the tools that goes around it to do the full PCB analysis, the whole enchilada basically. So you get a full package, right? And some other aspects, which is IP exact. This is you can use for register mapping. If you're developing a firmware, you can just take that as is and use it. And the next part is we want to be your trusted partners. To be your trusted partners, we want to support you through the process. We want to help you go from architecture phase to deployment phase. We start working with you on the architecture. We know the protocol well. Depending on your application, we'll guide you on what features you should have, what you don't need, why. We actually work very closely. Our architects in-house will work with you on that, right? We go through the silicon bring up. We'll give you platforms to do the silicon bring up and get it to market faster. There's a case that one of my customers, small startup, they needed help. Right? We sold them IP. That's all we sold them. But we helped them fix their package issue. We helped them fix their demo board as part of our IP set, which we didn't have much to it. We didn't have anything to gain there, but we did it anyways because if you succeed, we succeed. I've had 3 generations of designs with them now. So we truly believe in that. Actually, our CEO, he was voted one of the most connected tech person, period, in the world. So he's a relationship person, so it flows through the company. Partnerships, right? I don't have everything at my disposal. We don't have everything at our disposal to give you to develop your design, right? We have a lot of it, but we don't have everything. What we do, we partner with some of the biggest names in the industry. TSMC. Who doesn't know who TSMC is? Okay, good. I'm glad I have the right audience here, right? So TSMC, one of our biggest partners, and we're investing a lot there, right? Whether it's tools or IP. We got 8 partner awards from them in the last 3 years. So that's testament that we're actually doing a lot of good work there. And we have multiple 7 nanometer platforms with them that we're just taping out, but not taped out, we've taped out, and we have them in-house that you can use as reference. Who doesn't know the second name? Okay, good. So good audience, right? Biggest IP vendor out there, right? We don't have processors. We have DSP engines, but we don't really have processors. So what we do is work with ARM. We work very closely with them, whether it's their server platform, whether it's their mobile platform, IoT platform, all across the board, right? One example here is so they had a mobile processor core. I'm not allowed to speak which one, but mobile processor core. We put all the IPs around it. 3 engineers, 3 months, the whole platform here ready, done. Demonstrating multiple things. I can't even tell you half the things, but yeah. So, third, you guys, right? Our biggest partners are our customers, right? We want, if you're engaging a new process node, you're going in 7 nanometer, or for consumer technology going in 28, right? It varies depending on application. We will work very closely with you, fine tune it. With the first couple customers, we work very closely. We design a solution for you. We take that and productize it. That's how we make our business profitable too, because we amortize the cost across multiple customers, multiple designs. But we always work with the lead customer. That's what we focus on, is advanced technology. Our most design wins are on 16 nanometer and 7. We don't have previous older generation. We don't try to do that either. Right? Tools. Cadence is an EDA company. That's our bread and butter, right? So the one advantage, you get the IP, you get the whole toolkit along with it, fully verified, everything's taken care of. And what I've mentioned earlier is we're not just looking at the chip silicon level. We go beyond that. Package, board, and the full system rack level enablement, the full physical design of the rack. So high level, that our vision is to basically, we want to tie our success with you. You succeed, we succeed, right? Simple. And then go beyond just the IP and the chip. So now I'll go over some of the more technical stuff. It'll be still very high level for those who are familiar with these. So we focus on 3 markets: data center, enterprise area, mobile, and automotive. All 3 areas have different requirements, right? For data center, I need performance more than anything else. So I'm looking at bandwidth, latency, reliability, RAS. Does anybody know what RAS means? RAS features? Nobody? Nobody has developed a product for data centers here? You have? Okay, what is it? Availability and serviceability, right? So it's mostly reliability, right? Mobile, no brainer, right? My phone barely lasts a day, with the amount of power it consumes. So power is huge. And my phone, some people like the big phone. I don't. I like it small. So, area is important, right? Power, area. Area also translates to dollar. The smaller your die size, the cheaper it is, right? And performance, obviously. You do want to update every year or so. Automotive, no-brainer. As I mentioned earlier, you're looking at safety and reliability as the top 2 features. And then everything else comes later. Whenever there's life at risk, you want to focus on the safety side of things. So how is this relevant? We basically take our IPs and put them in these 3 buckets and optimize 3 different flavors of each of them that apply, right? First, in the IP data center, I want to focus on, we have Tensilica cores too, but DDR, PCI Express, 2 of our key IPs there. First to market 16 nanometers, first to market 7 nanometer, both. We have the highest performance out there, right? We actually have customer designs in play on 7 and 16. We have them in production, right? Who knows C6 here? Who knows what CCIX is, by the way? PCI Express? PCIe? People know PCI? Okay. So, quick primer here. C6 is cache coherent interconnect for accelerators. So data centers, I don't know if you followed, Microsoft did this big announcement on Azure. They basically take Intel CPU with an Altera FPGA, and they do all the acceleration functions on the FPGA. Same thing with GPUs that NVIDIA does. So that's basically, you need a way to connect these two in a much better way than just PCI Express. Right? So C6 is meant to achieve that. It's cache coherent, so basically the whole system from a programmer's view looks like it's a single memory that's spread between the CPU and your accelerator. Very efficient to develop your application, and second, the performance is really good. So we kind of target that. We were the first to get C6 solution out there deployed. Who here is familiar with the SerDes? Or do you even know what SerDes is? Okay, good. I had a different crowd earlier today, so. So from a SerDes perspective, I'm looking at, for PCI Express, you're looking at 16 gigabits per second. It was just ratified, the Gen 4 standard. We have a very unique architecture which has actually been very, very successful. We can have a single PLL drive the entire 16 by 16 lane of PCI Express. Very few vendors are able to do that. What that does is, A, you get the performance, but you get the area reduction and power reduction because you have a single PLL driving the entire database. Right. We also had one of the lowest L0 state power and latency that's applicable for the mobile space. Not really meant for data center as much, but it is becoming more and more important in data centers too. We were the first ones to have a Gen 3 controller in the market. Gen 4, we were the first ones to get compliance on Gen 3, but we because Gen 4 compliance is not ready yet, but we were the first ones to take it. Mobile space, you'll hear the term PPA. Who knows? I mean, you can probably read it from here, but PPA is, it's right there. But PPA is a commonly used term, right? Whenever you're getting IPs, that's what you use a lot. In mobile space, usually it's power, which I discussed earlier. Then you're looking at area, then performance, right? We have a lot of IPs in this space. And the good thing is most of these IPs go straight to the automotive space. Almost all of them, actually. So automotive is a mix of data center and mobile, as you can imagine, because they're saying the car is going to be the next data center and a smartphone moving together. Right. Again, one star IP here we have is LPDDR. What does LP stand for in here? Anybody? Okay, good. Thank you. I had to quiz that. Nobody got that answer last time. So LPDDR, this is a memory interface to your RAM. We have silicon running at 4266. There are no chips out there that can run that fast on the memory side. There's no DRAM out there that runs that fast. You can't even sample that. But we have it, right? And you're running without overdrive or any special features. So you're going to run very low power there. Like I said, automotive, almost exactly the same IPs as the mobile space, with some exception. You got PCI Express 4, and actually even C6, which is developed for data centers, making its way here, right? So focus on. Notice I'm not talking about performance PPA here. It's all safety. So some of you probably understand the terms. Who knows what FMEDA is? Okay, the automotive guy knows. Okay, anybody else? I wish I had some giveaways to give, if you got an answer. So failure mode, error diagnostics and analysis, right? Did I get it right? No. Okay. No. So this is basically what you do. You prepare a report. Anything that can fail, you do safety manual. You basically look at a piece of IP or block. What are the functions? What can fail? How? What is the probability? You have to hit a certain numbers just to make sure everything is safe. You add redundancy to make sure there's a backup, right? Say you have your sensor, you're going in a Tesla in autopilot mode, the camera in the front fails. You got to know that right away, or you got to have a backup camera, otherwise you're going ramming into someone, right? That's a problem. So safety, huge. ACQ 100, who here knows, except for you, who here knows what that means? ACQ 100. I hate acronyms, which is why I'm describing all of them. So you can look smart in front of other people. I don't even know what the acronym means there, but it is for reliability. Right? It's automotive grade, so it defines how much reliability, how long it should last, 10 years, what's the temperature range it should manage, so on and so forth. So these are some of the things that we do to make sure the IP is automotive grade. You'll see that being thrown around a lot, right? It's not just the device, it's actually the IP itself is getting automotive grade too. One of the star IPs we have in the automotive space, Ethernet. So I don't know. So on the automotive space, the big thing is, did you guys know the wires, just the wiring in a car, weighs about a third of the car weight? It also costs about a third of how much a car costs. Just the wires, the wiring running in a car. It's crazy. So one of the big things that they're trying to do is basically replace that and take an Ethernet two-wire connection and run that through the entire car. Take out that whole entire weight and cost, right? So automotive Ethernet, huge area of discussion right now, right? You basically want to run a little network that's running, which you have at your office or something, in a car, right? But to make sure it's reliable, there's something called TSN. TSN stands for time-sensitive networking. It ensures if I'm getting some data, this is the latency. It has to happen within a microsecond or at 10 milliseconds, so on and so forth. So they define latency, so you make sure there's redundant data. Any safety critical data gets there without fail. If something fails, you get to know right away, and everything shuts down, sort of, right? So this is something that we developed. We were first to market. We have it out there. We have multiple vendors already using it. We didn't even know half of them were already using this for automotive functions, because it gets used in the industrial space too. So another star IP. So overall, our strategy is, depending on your application, we'll create a star. We have the key IP that you need, and the rest comes along, right? There's a key IP you need to make sure you can enable that application, right? So as I said, by now, I should be your BFF, right? In terms of IP, if you're doing your chip design or solution design, we want you to help you build the future faster by using our IP. All right? I'll take questions if there are any.
Yeah, any questions for Sachin? All of the Cadence IP is located on ChipEstimate.com, and we can queue it up. Yeah.
Yes.
Here.
You mentioned the TSMC standard for IP.
Yeah.
Now, is this something you have to actually manufacture as silicon and then look at it? Because most of the other standards you mentioned, ASIL and the AG, you actually have to look at it on silicon. But when we think of IP, we don't really typically think of silicon. It's pre-silicon.
Right.
So how is it different with the TSMC compliant?
So I'll go over that. So the question is, how is the TSMC process different from the other, right? So I'll give you a little primer here. First is, there's a standard body called ISO 26262. I have a peer over there who may have done a PhD there. So that basically defines the process. So ISO 9000, you guys are familiar with that. That's the quality, right? 26262 is applicable to automotive. It's a recent thing, 3 years ago. They basically defined all the processes, how you document things, you trace everything, how you do the analysis. So in case there's something happens, somebody dies, there's a lawsuit. This is the body you go to. It puts checks and balances that there is this safety band here that you point to the ISO 262. These procedures were followed, so you can point to where the problem happened, so you go straight to that source, right? It gives you protection to a certain degree, right? The ISO 262 is independent body, right? So we work with an independent auditor. They come in, they look at our all analysis. They say, okay, this is good. Your ASIL ready, right? FMEDA, right? FMEDA is a superset, so that's part of that, right? Second is ACQ 100. That's the reliability. So that's on silicon. You do that on silicon. You basically characterize each part. You have roughly, I think, 900 parts that you have to characterize over, beat them up to death to see how long they last. So you do burn-in tests, basically make sure they will last 10 years of life at least, right? That's grade 2. Grade 1 is even worse, right? At 125C, running up to 10 years. You want to make sure it runs that. Then TSMC, they have their own program that they adopted from learning through the automotive market out there, and they combine the two. So they've put together checks and balances within TSMC. That's what they call 9008.